Um, we are going to be looking at sampling introduction. So we're doing a new section, chapter 5. If you wondered what happened to chapter 4, it was never in the list, right? It was never going to be done. It deals with things that we don't cover. So we're going to look at the whole idea of how to collect good data. And also get used to the jargon of the terms. So let's suppose that I'm going to make a story up so that I can use it throughout this process. So suppose we are interested in high school students and how many of them drink alcohol on a regular basis. So we're interested in collecting basically information about high school students and how much of them drink alcohol and how much do they do and all that. It could have been drug usage, which they're very interested in because that's one of the ways we keep track of what are the drugs of choice amongst high school students, and be very prepared to tell them to stop doing it for starters. Now, how would you collect information? And you're interested in all Americans. So I guess I should put United States of America high school students. And you want to get, maybe things like what percentage of them drink alcohol at least once a week? What percentage of them don't drink alcohol at all, right? All sorts of questions to do with that. And the problem is we need to collect data. Now, there are two major ways to collect data. One is called a census, and the other is called a sample. Now, before you get to the point where you decide which of these two methods of collecting your data is, you need to know what's called your population. And essentially, the population is everyone of interest in your what do we call that, in your story. So I'm interested in my story on the drug usage of high school students. So my population would be all American high school students. So would you agree it wouldn't be very good for me to go over to France and find out what French high school students do, because they're not my population. And it wouldn't be much use if I just went out on the street and asked, adults what they thought, because they're not high school students either. So once you know who your population is, then that decides how you're going to tackle this question. A census is a very expensive way to do it, but it can be done sometimes. And that's where you ask everyone in the population. So you have to know who the population is before you can ask everyone. Now, what is the problem with that? Well, the good news is that you get very accurate data. The best data in the world, essentially. But what are the negatives? Well, that's the positive. The negatives, well, there's a few of them. The first one, the major one, it's very expensive. That's the major problem. There are others, but that's the major one. It's very expensive. Can you imagine how much money it would cost? The bureaucracy, the people that you'd have to pay to go and, ask every one of these students, right? The money with the people who, once the data came in, had to process it and figure out, what was going on. After expensive, it's very difficult to do. If I went and said to you, I want you to find some totally innocuous, right? I want you to find the color of hair of every high school student in America. Where on earth are you going to start? Right. I guess you'd need to find out first all the high schools in America, where they are, right? Wouldn't you also then have to figure a way of going there and asking all the students? I guess before that, wouldn't you have to get permission to do it? Can you just imagine the multitude of problems? And then there's some practical problems. Shouldn't you do it like on the same day, at the same time everywhere? Otherwise, couldn't a student leave one high school and go to another one? And you'd miss them. What are you going to do about all the homeschooled high school students? Isn't that going to be even more difficult? Very expensive, and it's difficult. Who are the only people in the world who do censuses? Governments. Don't you do one every 10 years? I think you do a baby one every 5 years, but don't you do a major census? It's called a census, actually, right? Every 10 years. Why? Because they have the money, right? Government don't care what something costs. If they need it, they do it, right? Censuses. So what is the typical way that we collect information about anybody? Is we collect a sample. And a sample is a small, typically small, representative group of people from the population of interest. Now, I'll make up a number. I can't ask 20 million high school students about drinking, right? It's just impractical, expensive. I couldn't afford that. But I could use a small representative group of people. And then I would be using the results from that to make a conclusion about what the population would be. Now that process of, let's pretend I got a group of 200 students and I found out half of them drink alcohol on a regular basis. Then what I could say is, I believe half of American students, high school students, drink alcohol on a regular basis. See, if you pick a good sample, won't that sample represent what the population is doing? So if 10% of the sample does this, you can make the prediction that it's probably going to be around about 10% for everyone. Now, what are the pluses? Well, the pluses is that it's cheap to do, relatively cheap at least. That's a definite plus. 2, it's relatively easy to do. That's a plus. Do you see it's the exact opposite of these things? It's expensive and difficult, it's cheap and it's easy. So what are the negatives? Well, this is very accurate. This is less accurate there. Can you imagine if you only asked 400 high school students, even with the best will in the world, couldn't you be a little bit out with your final results compared to what the population is like? How could that happen? Well, I'll make this up. High school students in Alaska might drink a lot more than high school students from Florida, right? But if I'm only going to ask 400 students, couldn't I end up only asking 10 Alaskans? Because there are not many population-wise. Can you see that that could easily give me distorted data? The only way you can reduce the accuracy is by asking 4,000 or 40,000. But you know, the more people you ask, don't you get closer and closer to being a census? And that means it becomes more expensive and more difficult to do. So in general, censuses are very rarely ever done. So we tend to focus on samples. And sample is a small representative group of people. And this process of using your sample to make predictions about the population. This process is called inference. You know, I'm trying to think of a sentence with inference in. Do you know that sometimes you make it, you infer something from what you know, right? I come into my house and my couch is ripped apart. I might make the inference that my dog decided it had a bad day and took it out on the couch. Now, I wasn't there. I didn't see the dog doing it. Would you agree the evidence is probably aiming towards that, if that's the only animal I have in my house? Now, I could be wrong. Couldn't a raccoon have sneaked in through the doggy door and ripped it up? Yeah. Don's little kid could have had a bad day and just decided to rip it up because he wanted to, right? But the most likely cause would be my inference that it was my dog, right? That kind of thing. So it's a kind of logical conclusion based on the information that you've got. That's what an inference is. So in our story up here, if half of my sample say they drink alcohol, my inference would be half of American students drink alcohol, high school students. Any questions so far about that? I told you there are a lot of, notes today because it's a very, I don't know what to say, very wordy thing that we're doing. Okay, so, and let's give you an example of population versus a sample. So here's my first story. A political scientist surveys 300 votes randomly selected from registered voters in Bremerton. The purpose of this is to estimate the proportion of them who are going to vote in the upcoming election. So they don't care who you're going to vote for, they just want to know, are you likely to vote? And so I guess you find these people and they say yes or no. What is the population of interest here? In the story I just gave, what is the population of interest?
Voters in Bremerton.
Yeah, registered voters in Bremerton, agreed? Which, by the way, they can't ask me, or they shouldn't. Why can't they ask me? I'm not registered to vote in Bremerton. I'm not an American. And I'm not allowed to vote. So I don't, because I'm very honest. So if you asked me, I would have, I've done this. You know, when you do petitions and people stop me and say, you want to sign this petition? I tell them I can't. I'm not an American citizen. I shouldn't be taking part in any of those things because I don't vote, right? I pay lots of taxes, so that's good. And do you remember the American War of Independence, or the Insurrection War, if you prefer, started because no taxation without representation? Remember that? Do you think I should start my own little insurrection? Because I do pay taxes, but I can't vote. And I'm going to go to Boston and I'm going to find Coca-Cola, because you have to, move up in the, the history. It used to be tea, yeah, but Coca-Cola, and take cans of Coca-Cola and throw them into, is it the Potomac? I think it's the river up there, whatever it is. Throw it into the river and start a small revolution. What do you think would happen to me?
You'd be immortalized.
Oh, I thought you were going to say they kick me out of the country, which is more likely.
I was going to say nothing would happen because they just use like a big net and fish them out because cans of Coke float. So
Okay, so nothing too serious would happen. That's good. So in that story, then it was registered voters. Wouldn't the sample in that story be the 300 people I asked? So it should be easy to tell what the sample is and what the population is. Suppose the next story is that you wanted to estimate the percentage of American households that using a streaming movie subscription service, you know, like Hulu or Amazon or that, right? And so they asked 600 households. What would the population be in that story? They want to find the percentage of American households that watch Hulu, you know, prescription services. Lauren.
Wouldn't the population be the people who have streaming services?
No, strangely enough, it's bigger than that.
People who have internet access.
Even bigger than that. It's just all the households in America, every house in America that has a person in it. Because then you're going to say, do you do a streaming service? Yes or no? So the answer can come back, 42% of American households watch a streaming service. If you only asked people who had a streaming service, wouldn't the answer be 100% of people who have streaming services, right? So your population is the bigger group. The sample is the 600 people that they asked. Are we good so far? Now, let's look at, back to some notes here. Let's look at some, whoops, excuse me, some problems with using samples. And there are lots of them. And so I'm going to be spending a fair amount of time, and I'll probably miss some. And that's okay, because when we look at the homework questions, I'll probably find out, oh, I didn't mention this one to you. Here is the first one. When you have problems with a sample, they use the word bias. So you'll find that word I've got. So first one we're going to do is called selection bias. Right, selection bias happens when you pick your sample in such a way that it's not a fair representation of the population. So your sample is not a fair representation of the population. Let's give you some examples of selection bias. Suppose I was interested in the percentage of adult Americans who watch football live. In other words, they go to a football match rather than watch it on TV, right? What percentage did that? If I got a sample of 1,000 people, 1,000 adults, and it was 900 men and 100 women. Can you see that that sample isn't a fair representation of the population? Roughly, very roughly, isn't it 500 men, 500 women would be a fairer representation? Okay, agreed? Now, if I chose that combination just to be sexist, isn't there a good chance that I would get a lot more people saying that they went physically to a football match, because maybe more men go to football matches live than women do, right? Just out of argument's sake. Can you see that there would be a bias in the answer? In other words, my answer wouldn't be as accurate as it could have been if I did an even split. Does that make sense? Suppose I'm interested in what percentage of Americans drink alcohol at least once a week, right? And I decided to take a sample of 1,000 people. And because I'm lazy, I just went into bars and asked people, would you agree that is over the top selection bias? In other words, you go to a place where there's a lot of people who probably do what you're interested in. So in this case, you're interested in people drinking, you could go there, right? Would you agree that that sample would not be a fair representation of all Americans? Right, people that go to bars don't. Now, couldn't I go to a church? Wouldn't that be biased in probably a slightly different direction, right? Less people drink, I'm assuming. Can you imagine politicians doing that? I want to know the percentage of American voters who are interested in, I don't know, increasing the child allowance. Couldn't I go outside kindergarten and talk to the parents as they're coming to pick up their kids? Couldn't that sample be a selection bias? Right. So you don't want to pick people who are different from the population in a way that's significant. Now, suppose I wanted that same questions answered that I just gave, and for some weird reason, I just decided to ask people with brown eyes. Unless there's something I'm missing here, do you think brown eyes has any effect on drinking alcohol or whether you're in favour of childcare or anything else? And I would think no. So can't some biases be not important, right? Colour of somebody's hair is probably not going to be the biggest influence on how you're going to vote or any other thing. So that's selection bias. 2, non-participation bias. This happens when a large number of your sample choose not to answer. Your question. So non-participation bias. Let's think of one. You send out a questionnaire to 1,000 people. And in your questionnaire, you ask them, who are you likely to vote for in the next election? And let's just say that people who are Scottish Republicans, right? So people who, well, Scottish Republicans are a bad one, are royalists, don't want to tell people that they would vote royalist. They want a king back, right? They want a king of America, right? I'm trying to be apolitical here by not picking one of the other two, right? So they don't want to tell people that, right? For some reason or another, they have chosen not to answer that question because they fear the ridicule or the problems that it might generate. Can you imagine some people might have a problem telling you that they would vote for Donald Trump if he came back again? I could imagine that being a non-participation bias issue, right? So if people choose not to, and it's a large enough number, so if you ask 1,000 people and 2 people don't answer you, that's not a problem. If you ask 1,000 people and 200 don't answer you, couldn't that be a big problem? Right? They're not answering, maybe there's a good reason for it. The third one has a name very similar to it. It's called the participation bias. So if you're wondering what does the homework questions look like this, they're full of reading. They give you a story and you tell me what kind of bias it is. Or they give me a bias and then they give you 4 stories and say, which one of these is a non-participation bias? Or which one of these is a selection bias, right? For example, right? Participation bias is when people choose to take part in the sample. Can you imagine a guy on a radio station says, phone this number if you're in favor of abortion, and phone this other number if you're against abortion, right? So you're on the radio listening to the show, and the guy tells you, phone 123-456 if you're in favor of abortion, 123-457 if you're against abortion. Ever been in the radio when they do things like that? That is an example of participation bias. Don't you phone, that's you taking part, you're now in the sample. What kind of people phone those things? Well, don't they tend to be people who have strong opinions on whatever it is the question's about? So the participation bias tends to make the people who respond to it tend to be different from the rest of the population. They tend to be different in the sense that in many cases, they're much more in favor or against whatever it is. Whereas maybe a lot of the population, I'm not too bothered one way or the other, or I'm slightly in favor of it, but I'm not that in favor of it. I'm going to go through all the trouble of phoning you to tell you, right? So you don't get a good representative grouping when you do participation bias situations. So any phone in thing. Have you ever been in your website and this annoying thing comes in and says, are you in favor of this? Click this to vote. You ever had one of those things? Do you know that's a participation bias? And then the next day they say 90% of Americans are in favor of this. And the reason I know it is because yesterday I did one of my little polls online. Not very accurate. Participation bias. Right, out of those three, anything you're not sure about? Okay, let's do a little story. I'm going to give you a story and it falls into one of these three categories and you tell me what bias is being generated here. So you're interested in how many adults use vape machines now, right? And so what you do to collect your information is that you go to a casino and you watch people and you register how many are vaping and how many are not. Why? What's wrong with that sample? Which of those three does it really fall into? You went to a casino and just looked at what percentage were vaping.
I believe it'd be selection bias.
It is. Because you're interested in all American adults, not just American adults that go to casino. Would you agree that not every American adult goes regularly or anytime even to a casino? Right? That would be an example of a selection bias. The group that you're choosing could be different, couldn't they, in some way from the general population? Well, for starters, they gamble. That's the difference. Suppose you had a TV program and you were watching it. It's one of those political programs, right? And it was on MSNBC. And they went and said, text yes to this number or text no to that number. And they wanted you to vote on something, whatever it might be. What kind of bias is that situation?
Participation bias.
Yeah. Directly, isn't it? In the sense that you can choose to text or not. It's actually, because it's okay to be more than one bias, isn't it also selection bias? Would you agree that people who watch MSNBC are not necessarily the same people who watch Fox News. Can you imagine your sample is only being collected from a subgroup of the entire population of adults? So you know, who you ask is important, and how you ask is also important. Oops. Then moving along a little bit, I'll tell you about a very good sample. A very good sample is called a simple random sample. It's the holy grail of sampling. Companies who collect data, right, for whoever it is, it could be for political parties, it could be government collected data, it could be any kind of data. Try and get a simple random sample. In a simple random sample, every member of the population has an equal chance of being chosen. For the sample. So in a simple random sample, every single person in the population has the same chance of being chosen for that sample as anyone else. And that is like the best sample in the world, because what that tends to generate is a fair representation of the entire population, with one very important caveat. Make the sample as large as you can afford. Why do you think that's in? That in a simple random sample, try and make the sample as large as you can afford it, right? Because it costs money to do these things.
The more data, the more accurate the average.
Yeah. Would you agree that if you only ask 10 people, there's a lot of leeway for just getting unlucky and bad data? But if you ask 10,000 people, would you agree, okay, you're going to get a couple of weirdos in that 10,000, but aren't most of them going to be pretty much like everybody else, pretty random, you know, a pretty representative sample of your population, right? So we have rules, and you'll find out as we go on that the idea of how large is large will give you it. If you want to get one right now, do you know that most companies that you pay money to do this? So that's, you've probably heard of them. Ever heard the Gallup poll, for instance? That's an organization that does sampling for political parties and for commercial people as well. The going rate for a sample is slightly over 1,000. So most of the time, if you went to them, they'd probably say, well, we have a 1,000 sample, you know, this will cost you X amount of money. If you want a 10,000 sample, obviously it'll cost you 10 times as much, maybe a little discount, and, you know, all the way up to who knows how big. I mean, if you're Bill Gates, you could get 1 million people sample and pay for it if you wanted to, right? But they tend to do about 1,000. It tends to be 1,000 in a couple. And the reason why they have 1,000 in a couple is that no matter how innocuous the question is, don't you get a couple of non-responders? Like, even if I went and said to you, have you ever been to France? But I can't think anybody being that offended by that question. But there are always a couple of people who say, I'm not telling you nothing, you're not the boss of me, right? So they make it like 1,010, and that takes care of that. So that they kind of almost always end up with 1,000 people with an answer. Perfect sample, if you can do it. So we've talked about samples that have problems. Here's one that doesn't. And there's a lot more of these, but I don't want to go into them yet, because I want to show you back to my sample things. I want to talk to you now about a different problem. Suppose you've got a simple random sample. SRS is typically used. And it's a good size. Let's say it's got 2,000 people in it, so I don't have a problem with that, right? But I do have a problem with this. Suppose I ask them something very, very sensitive. Like, have you committed a felony in the last year? Because maybe I'm interested in what percentage of Americans have committed a felony in the last year, right? Adults. Can you imagine the kind of problems you can get? Well, couldn't you get non-responders? Now, what implication could you have? Well, the reason they're not answering it is that they committed a felony. But couldn't the reason they're not answering it is because it's none of your darn business and I don't like telling people anything about myself? Can you tell which of those two that particular person is? I don't know how to tell. I can't read people's minds. Non-responders are very difficult. If you are going to ask a very sensitive question, you have to get around the problem that they could also do this. Couldn't they lie? No, I've never committed a felony. In a lot of ways, isn't that more likely? So if you just didn't, in some way or other, try and fix these problems, haven't you just spent a lot of money and you can't really be that comfortable that your answer is accurate? So what you need to do if you are asking sensitive information is that you need to find a way to try and reduce or eliminate as much as possible the people who won't answer you or the people who will lie to you, right? So let's do a different story. Suppose I was interested in the high school students again in drinking. And I got a perfectly good random sample, right? Wouldn't there be a problem that some of the students are going to lie? They're not going to admit to doing anything bad, right? You're not catching me in that one. I'm just going to say, I don't drink. So you might think, well, what do you do? I mean, you're kind of stuck. Well, not really. There's a number of ways that you can get better information. And one of the ways that they do, and it's pretty successful, at least I believe it is if you're doing it with the students, the first thing you do with the students is isolate them. You don't have them in class. Stick your hands up. How many have drank this week? Right? Would you get, okay, you know what I mean? The chances that you're not going to get accurate data. So you isolate them. In other words, you do it one at a time. Second thing you do is you make them feel safe. You give them a piece of paper and you say, you write down your answer on this piece of paper, yes or no. You fold it up and you stick it in that box there. Oh, by the way, nobody's name is on these pieces of paper, and that box there has all the other answers. So you fold it up and you stick it in the box, give a good shake. Nobody knows what your answer is now. Can you see that you might motivate them to be honest? So no fear of repercussions, no fear of people knowing who they are, no peer bias. Because if you go into high school and one of them sticks their hand up, don't they all stick their hand up because they all, peer group pressure, right? You eliminate those. That's how you tackle that problem. Difficult to eliminate totally, but at least you can reduce it to the point where it would be working, right? So that is a classic problem with collecting data. Suppose I had a simple random sample of 10 people. And I asked them a very innocuous question, like, have you ever been to France? What's the problem with that sample size? Would you want to make any inference about Americans going to France based on a sample of 10 people? I wouldn't. So what's the problem?
It's too small.
That's all. Sometimes the obvious answer is the right one. If I was really unlucky, couldn't I end up picking 10 people that'd all been to France? I mean, it's highly unlikely, but it could happen. I win the lottery, you know, I haven't been good, right? Could happen. If I did that, wouldn't I come up with a really weird, everybody in America has been to France. Suppose it was 0. Couldn't that happen? Ask 10 people and not, I've never been to France. Let's do that as our little finish for today. It's not quite 10 people. There's 2, 4, 5, 6, 7, 8. There's 18 of you. How many of you have been to France? Do that little hand up thing if you don't have your picture. Wow. Nobody in America has been to France. I mean, that's what this sample said, isn't it? Nobody's been to France. I bet you know somebody who's been to France. Well, actually, you do, because I've been to France. I didn't vote there because I was a non-responder. Could you even tell I was a non-responder?